Hello and welcome to our lesson on conditional probability. Conditional probability is a probability that's based on a condition. I bet you never would have guessed that, right? So what does it mean to be based on a condition? So what's going to happen is you're going to have a condition that's limiting your universal set. It's going to limit what you're looking at. So for instance, when you go to choose a card from a standard deck of cards, you've got 52 options, right? A conditional probability might say, instead of what's the probability of choosing, I don't know, an ace, it might be something like, what's the probability of choosing an ace given that you've chosen a red card? So if you know that the card is red, then you're no longer looking at all 52 options in the deck, you're only looking at the red cards, so the bottom of your fraction is a smaller number. It's limited to a smaller set of cards. So a conditional probability limits the universal set. It's based on a condition, and the condition limits, it makes smaller the number of choices, the universal set. And you will not always, but you will often see the words given that. Given that. What's the probability of this happening given that this has already occurred? And there's notation for this. The probability of A occurring given that B is some condition or that B has occurred looks like this. What is the probability of A given that B is a condition? Okay, that's that little line in between there. We use that in do you remember the set builder notation? We say A such that B. This is a similar concept here. So what's the probability of A such that B has already happened? Okay, but in this case, B is our condition. Okay, so example 1, let's show you how this works. A single card is selected from a standard deck. We've done this before. This one says, what's the probability that it is a club given that it is black? So you can see the notation. What is the probability that you're choosing a club given that the card is black? Okay, when you're working on these conditional probabilities, what you want to do is limit your universal set first. So determine the bottom of the fraction first, and then of that limited set, what do you have going on the top? So what's the probability you choose a club given that it is black means we are only looking at the black cards. So how many black cards are in the deck? There are 26. So of those 26 black cards, how many are clubs? Well, 13 are clubs. And so this makes this answer 1/2. Okay, the probability of getting a club normally would be 1/4, but because we're only looking at the black cards, it's now 1/2. So for these conditional probabilities, you want to determine the bottom of the fraction first. So use the condition to find the denominator first. Okay, and then out of that limited group that you've put in the denominator, then go back and figure out how many go in the numerator. Okay, let's try that again. So number 2, a single card selected from a standard deck. What is the probability it's a 4 given that it's a heart? So find the probability that you choose a 4 given that the card you chose was a heart. So what that means is we're not looking at picking a card from the entire deck of cards. We're given that the card is a heart. So we know that we're only looking at the 13 hearts that are in that deck. Okay? Of the 13 hearts, how many are 4s? Only one of the 13 cards is a 4. So 1 out of 13 is our probability. So 1 out of 13. Okay? How about you roll a die? If you roll a dice, I'm assuming a 6-sided die since it doesn't state otherwise, what's the probability of rolling a 2 given that the number rolled was even? So what's the probability that we roll a 2 given that the number we rolled was even? So normally there would be 6 options, right? You'd have a 1, a 2, a 3, a 4, a 5, a 6. Now they're saying the number we rolled was even. So that means this isn't an option, this isn't an option, this isn't an option. There are only 3 options. There are only 3 even numbers to choose from. Of those 3, how many are 2s? Just the 1. So 1 out of 3 is our probability. Okay, 1 out of 3 is our probability. All right, how about this? A two-way table. We saw one of these in the last topic. It says 200 patients who had either hip surgery or knee surgery were asked if they were satisfied, dissatisfied, or neutral regarding the results of their surgery. And it appears that they were all either satisfied or dissatisfied because we don't have any neutral. So we have, let's see, 95 people had knee surgery, 105 had hip surgery for the 200 total. And then we have the other direction. Let's see, we have 160 satisfied and 40 dissatisfied for, again, the 200 total. Okay, so some in all of those categories. So if one person, oops, I swear, one person, so it's just one probability that we're looking for, is selected, what's the probability that that one person was satisfied? So this isn't a conditional probability, this is just what's the probability that they're satisfied. Well, there are 160 satisfied out of the 200 total. So it's just 160 out of 200. And again, if you don't like reducing fractions, you can let the calculator do the heavy lifting for you. 160 out of 200 is 4/5. So our probability would be 4/5. Okay? How about B? So again, you're selecting one person. What's the probability that one person is satisfied with the results given that they had knee surgery? The probability they were satisfied given that they had knee surgery. Okay, if we're given that they had knee surgery, that means we're not looking at everybody in this table. We are only looking at which people? The ones who had knee surgery. So the knee surgery people, right? This is these 95 people. So out of the 95 people that had knee surgery, out of these 95, how many were satisfied? 70 of them. 70 out of the 95. So 70 out of the 95 is our probability. And again, we can let the calculator do our reducing. 70 out of 95 becomes 14 out of 19. So 14 out of 19. Okay, let's try that again. What's the probability, again, we're selecting one person, that they were dissatisfied with the results of the surgery, given that they had hip surgery? So this is the probability they were dissatisfied, given that they had hip surgery. Okay, if we are given that they had hip surgery, that means that's all we're looking at. We are only looking at the, let's see right here, the 105 people who had hip surgery. Okay, so of those 105 that had hip surgery, how many were dissatisfied? 15. Okay, so 15 out of 105. Dissatisfied was the 15. And again, let's do some reducing. 15 over the 105 becomes 1/7. 1/7. Alright, so there's another one left from this table. If you're feeling confident with this and you want to pause and give it a shot, I think this would be a good opportunity to do that. If not, let's see if we can distinguish between Part C and Part D. So Part C was what's the probability they were dissatisfied given they had hip surgery. D is what's the probability they had hip surgery given that they were dissatisfied. What's the probability they had hip surgery given that they were dissatisfied? If I flip the order, does it change the answer? Absolutely, okay, because now we're not looking at the hip surgery people. Now our condition is that they were dissatisfied. So now we're looking at the dissatisfied people. That's these 40 total, okay? So of the 40 dissatisfied people, of these 40 dissatisfied people, how many had hip surgery? 15. So 15 out of 40 instead of 15 out of 105. And 15 out of 40 reduces to 3 out of 8. And there we have it. Okay, so conditional probability, again, limiting the set. We want to establish the universals, or establish the limitation, the bottom of the fraction before we try to do anything else. All right, let's look at another example. We've got another two-way table here. It says we have information concerning the age distribution of U.S. residents. This was based on a 2005 census survey, so population data. and these are rounded to the nearest million. So basically, in 2005 in the United States, there were 31 million males ages 0 to 14, or 21 million females ages 65 and older. Okay, so we've got males and females, and then we have them broken into their age groups. Let's try to find some different probabilities. So let's see. A is not a conditional probability. We're just, again, choosing one of these individuals at random. What is the probability that they're male? Probability that they're male? Well, there are 145 males out of the 295 total. So that's just going to be a straightforward 145 out of 295. And I know it reduces, but I don't want to do it. So 145 out of 295 is 29 over 59. 29 over 59 there. Okay, what's the probability that they're aged 15 to 64? Again, that's not a condition. Probability they're aged 15 to 64. How many are aged 15 to 64? That's 198 out of the 295. 198 out of 295. And I don't know if that's going to reduce, so we're going to see. 198 out of 295 as a fraction is the same, so it doesn't reduce. Okay, the next one says, what is the probability if we choose one person that they're a male, age 0 to 14? So this is two things happening at the same time. Males age 0 to 14. 0 to 14 males, that's these 31 out of the 295. So 31 out of 295 are males age 0 to 14. And I know 31 is prime, so that's not going to reduce. All right. How about here we have a condition, finally a condition. It says, what's the probability that they are age 15 to 64? Here's your condition. They're given that they're female. That means we are only looking at the females. So of these females, of these 150 females, right, 150 females, how many are 15 to 64? Well, in this group of 150 females, get rid of this. In this group of 150 females, how many are aged 15 to 64? 99. So this is going to be 99 out of 150. And that's going to reduce. I'm going to try to give myself a little more space here. Let's see. 99 out of 150 becomes 33 out of 50. So 33 out of 50 here. Okay, next one. What is the probability that they are 65 or older given that they're male? So in this one, we are only looking at the males. Let's see. Of the males, there are 145, okay? Of the 145 males, that's the bottom of the fraction, that's the limited group we're looking at, how many are 65 and older? 65 and older would be those 15. So we're looking at, that was an ugly arrow, sorry, 15 out of 145. What did I, guys, not that it matters to you, but I was trying to alternate colors, okay? There was 145 male, and 15 were 65 or older. And that's a million, but whatever. So 15 out of 145 is reducing to 3 out of 29. So 3 out of 29 there. And if you want to try the last one, if you're feeling good about it, go ahead and pause and give it a shot. Okay, this last one. Well, what's the probability that it's a male given that there's 0 to 14? So we are only looking at the 0 to 14. 0 to 14 is 61 total. Okay, 61 total. That's the bottom of the fraction. That's all we're looking at. Of those 61, how many are male? So of those 61, 31 are male. And that's not going to reduce. So that's our answer on that guy. Okay, hopefully you're getting the hang of this. Hopefully it feels alright. Just remember, you got to deal with the bottom of the fraction first if it's conditional. Alright, let's try this last one. We have a two-way table again, but some numbers are missing, so let's go ahead and fill those in. Let's see. Robert made a two-way table about the type and brand of shoes he owns. He's got Nikes, Adidas, Vans, some high tops, some low tops. So if he has 9 pairs of Nikes and 6 of them were high tops, that means if we subtract those 6 out, there have to be 3 left that are low tops. We can go across this way. So 6 Nikes and 2 Vans, that's 8. 8 taken away from the 12 means there's going to be 4 pairs that have to be Adidas. And then we can add this way. 4 and 6 makes 10 total pairs of Adidas. And there's a couple different ways to get this last spot, but if we have 24 shoes total, 12 are here, that means the other 12 have to be in that last box. So let's put 12 in here. Okay, now let's find some probabilities. So, let's see, what's the probability that one pair, that's one probability, one pair of Robert's shoes are low tops, given that they are Nikes? What's the probability that we select one pair of low tops, given that they are Nikes? So Nikes, in this case, are the only shoes that we are looking at. How many pairs of Nikes do we have? We've got 9. And of those 9 pairs of Nikes, how many are low tops? Well, of those 9 pairs of Nikes, 3 are low tops. So this is going to be 3 out of 9, or 1/3. Okay, what's the probability that one pair of Robert's shoes are Vans? I missed a word there. What's the probability that one pair of Robert's shoes are Vans, given that they are high tops? So the probability that they are Vans, given that they are high tops. So now, again, we're not going to be looking at all the shoes. This says we're only looking at the high tops, and high tops total are 12. So out of the 12 pairs of high tops, how many are Vans? So out of these 12 pairs of high tops, 2 are Vans. So 2 out of 12 is our probability, and that's going to reduce to 1 out of 6. Okay? How about if Robert decides to wear a pair of Adidas, is he more likely to wear high tops or low tops? So this is in a way a conditional probability. It says he's deciding to wear a pair of Adidas. That means we are only going to be looking at this column of shoes. So in the Adidas column there, is he more likely to select high tops or low tops? Well, the Adidas high tops. He's got, I should say probability of Adidas high tops would be 4 out of 10. And the probability of Adidas, I spelled that wrong. And I swear, I know how to spell and it's right there. Adidas high tops. Adidas low tops is 6 out of 10. And so which one's more likely? Well, 6 out of 10, 60%. It's going to be better than 40%. So we're going to say low tops. 60% is greater than 40%. A 60% chance is greater than a 40% chance is our rationale, and we showed that with the work. Okay? Now, let's see. This was 4 and 10 that I just erased out of there. Okay, last one. And again, if you feel good and you want to pause it, give it a try. It says, of all the shoes means the bottom of the fraction has to be all 24 of those shoes. What's the pair that a randomly chosen pair are? What's the probability that a randomly chosen pair are Nikes? So this is just, what's the probability that we choose a pair of Nikes? All of a sudden, I can't fix my colors. What's the probability that we choose a pair of Nikes? Okay? Of all 24 pairs of shoes, how many Nikes do we have? Of all 24 pair, there are 9 total pairs of Nikes. So 9 out of 24, and that's going to reduce to 3 out of 8. And that's that. Okay, so we've got conditional probabilities. Just look for those words that are limiting the total. Yeah, and you should be good. Okay, just make sure you're establishing the bottom of the fraction first if there is a condition. So as always, you have practice problems to try. Give them a shot, and if you need help, just reach out. I'm here for you. All right, take care.